Picture your car's engine as a living, breathing machine pulsing with energy and purpose. Every time you turn the key or press the start button, a complex symphony of moving parts comes to life under the hood, working together in perfect unison to propel you forward. At the very core of this intricate system are two vital components, the crankshaft and the camshaft. These parts are the backbone of the engine's operation, each playing a unique and essential role in transforming raw fuel into usable power. The crankshaft acts as the powerhouse, converting the piston's up and down motion into the spinning force that ultimately drives your wheels. As the pistons move, the crankshaft rotates, creating the rotational energy needed to move your vehicle down the road. Meanwhile, the camshaft serves as the engine's conductor, precisely timing the opening and closing of the intake and exhaust valves. This careful choreography ensures that the right amount of air and fuel enters the combustion chamber, and exhaust gases exit at just the right moments. These two components work in perfect harmony, transforming the explosive energy of fuel combustion into smooth, controlled motion. Their synchronized actions are what make the engine run efficiently and reliably, mile after mile. Without their coordinated dance, an engine would be nothing more than a collection of lifeless metal parts, unable to generate power or movement. The crankshaft takes the force from the pistons and spins thousands of times per minute, sending power through the transmission and ultimately to the wheels. This rapid rotation is the heartbeat of your vehicle's performance. The camshaft, on the other hand, ensures the engine breathes at precisely the right moments, controlling when air and exhaust flow in and out of the cylinders. This timing is crucial for maximizing power and efficiency. The relationship between the crankshaft and camshaft is truly the heartbeat of the internal combustion engine, setting the rhythm for every other component to follow. In the next scenes, we'll break down how these parts connect, move, and overcome the many engineering challenges that come with high-speed operation and extreme conditions. We'll explore the secrets behind this mechanical ballet, revealing how precision engineering and clever design keep everything running smoothly. From the basic principles that powered the earliest engines to the advanced technology found in today's vehicles, you'll discover what makes modern engines both powerful and reliable, and how they've evolved over time. So, let's dive deeper into the fascinating world of engine linkages and uncover the hidden mechanisms that bring your car to life every time you hit the road. At the heart of every engine's power are three key players: the piston, the connecting rod, and the crankshaft. These components work together in perfect harmony, forming the core of what makes an engine run. The piston is like the engine's workhorse. It captures the explosive force of combustion, moving rapidly up and down inside the cylinder. Each time the air-fuel mixture ignites, the piston is pushed downward with tremendous force, starting the chain reaction that powers your vehicle. The connecting rod acts as a sturdy bridge, linking the piston to the crankshaft. Its job is to translate the piston's straight line, up and down motion into a rotational force. This clever conversion is what allows the engine to turn linear energy into something that can spin wheels. As the piston moves, the connecting rod pushes and pulls on the crankshaft, causing it to spin smoothly. This spinning motion is the foundation of all the power your engine produces. The crankshaft is the main shaft of the engine, collecting power from all the cylinders. It combines the energy from each piston and delivers a single, powerful spinning output that can be used to drive the wheels or other machinery. Together, the piston, connecting rod, and crankshaft form what's known as the slider crank mechanism, a fundamental building block of engine design that's been used for over a century. In multi-cylinder engines, several piston rod sets are attached to one crankshaft. This arrangement helps balance the engine and creates a smoother, more continuous flow of power, reducing vibrations and improving efficiency. The precise timing of each cylinder's firing is crucial. It ensures that the crankshaft keeps spinning steadily, maintaining a consistent delivery of power and preventing any jerky movements. This entire assembly is responsible for generating the torque and horsepower that move your car down the road. The more efficiently these parts work together, the more power your engine can produce. Without the precise teamwork of the piston, connecting rod and crankshaft, engines wouldn't be able to turn fuel into motion. Their synchronized movements are what make modern transportation possible. It's a simple yet ingenious system that powers everything from tiny motorcycles to massive trucks and even industrial machines. No matter the size, the basic principle remains the same. Next, let's take a closer look at how the crankshaft turns all this motion into usable energy, making it possible for your vehicle to move forward. The crankshaft's genius is turning the piston's up and down motion into rotation. As combustion pushes the piston down, the connecting rod turns this force into torque, just like pushing a bicycle pedal. The crankshaft's momentum then pulls the piston back up, ready for the next cycle. This process repeats thousands of times per minute, powering the engine's four-stroke cycle. The piston's speed isn't constant, it's fastest mid-stroke and slows at the top and bottom, affecting engine breathing and performance. A timing mechanism, usually a belt or chain, connects the crankshaft to the camshaft. This ensures the camshaft turns once for every 2 crankshaft rotations, a golden rule for four-stroke engines. Perfect synchronization is essential, even a small error can ruin performance. This is the foundation of engine timing. If the crankshaft is the engine's muscle, the camshaft is its brain. The camshaft's lobes open and close the engine's valves with precise timing. The shape of each lobe controls when and how far a valve opens and closes. Smooth, rounded lobes suit quiet, efficient engines. Aggressive profiles boost high RPM power. The camshaft is driven by the crankshaft, rotating at half its speed to match the four-stroke cycle. This ensures each valve opens and closes exactly once per cycle. Even a slight timing error can cause major engine problems. The camshaft's precision is vital for performance and reliability. The connection between the crankshaft and camshaft forms the backbone of an engine's timing system, making it the most critical relationship for proper engine operation. Without precise coordination between these two components, the engine simply cannot function as intended. A timing belt or chain links the crankshaft and camshaft, wrapping tightly around gears that are specifically sized to enforce a 2-to-1 speed ratio. This means the camshaft rotates once for every 2 revolutions of the crankshaft, a ratio that is essential for the four-stroke cycle. This perfect synchronization is what allows the four-stroke cycle, intake, compression, power and exhaust, to function smoothly and efficiently, ensuring that each valve opens and closes at exactly the right time. As the crankshaft spins, the camshaft precisely opens and closes the engine's intake and exhaust valves, timing their movement to match the position of the pistons. This delicate dance is repeated thousands of times per minute. If this synchronization is lost, if a timing belt snaps or a chain slips, the consequences can be catastrophic for the engine. The entire timing system can fall out of alignment in an instant. In most modern engines, a timing failure means the pistons and valves can collide violently, causing severe internal damage that often requires extensive repairs or even a full engine replacement. That's why regular timing system maintenance is absolutely crucial. Preventative care can save you from costly repairs and unexpected breakdowns. Timing belts naturally wear out over time and must be replaced at manufacturer-recommended intervals to keep the engine running smoothly and reliably. Timing chains, while more durable, can stretch and lose tension, requiring periodic inspection and adjustment to maintain proper timing. Even a minor timing error can trigger engine performance issues, set off the check engine light, or lead to a complete engine failure if left unaddressed. In essence, the timing system acts as the engine's pacemaker, keeping every moving part in perfect rhythm and ensuring the heart of your vehicle beats strong and true. The crankshaft's motion is more complex than it seems. The piston's speed varies throughout its stroke, moving fastest midway and slowing at the ends. This non-linear movement creates vibrations and affects engine smoothness. Engineers use counterweights and balancing shafts to manage these forces. The torque produced isn't constant. It peaks after combustion and drops during other strokes. Multi-cylinder engines stagger power strokes for smoother torque delivery. The flywheel attached to the crankshaft stores energy during power strokes and releases it during the rest, smoothing out rotation. Without a flywheel, engine speed would surge and drop with every pulse. This balance is key to a usable, reliable engine. Engines are full of moving parts, creating powerful vibrations. Counterweights on the crankshaft offset the shaking from pistons and rods, making engines run smoother. Perfect balance is a hallmark of refined engines. Torsional vibration, twisting along the crankshaft, can be destructive if not controlled. Harmonic balancers absorb these vibrations, protecting the crankshaft from fatigue and failure. This small component is essential for engine longevity. Without proper balancing and damping, engines would quickly wear out or break. Vibration control is as important as power in engine design. The camshaft's lobes control how the engine breathes. Key cam profile traits are lift, duration, and timing. Higher lift and longer duration boost power, but can cause rough idling or risk valve piston collisions. Cam profiles must balance airflow, reliability, and smooth operation. At high RPMs, valve float can occur if springs can't keep up, risking engine damage. Engineers match spring stiffness to cam profile and engine speed. Racing engines may use pneumatic or mechanical systems to eliminate valve float. Every cam design is a compromise between performance and durability. The right cam profile is crucial for the engine's intended use. Camshaft design is both art and science. Modern engines use variable valve timing, VVT, to overcome camshaft compromises. VVT systems adjust cam timing for better low-speed torque and high-speed power. Advanced systems like VTC switch between cam profiles for efficiency and performance. This gives engines multiple personalities, smooth for daily driving, aggressive for acceleration. Engine parts face extreme forces and heat, so materials matter. Crankshafts are forged from high-strength steel and balanced for durability. Camshafts use hardened steel or iron to resist wear. Lighter, stronger materials help engines rev faster without sacrificing strength. The synchronized dance of crankshaft and camshaft is the soul of the engine. Next time you start your car, remember the engineering marvel beneath the hood.